Alright folks, today we're working on 10.1a, which is arithmetic sequences. We'll have a part B, which is geometric sequences as well. But for right now, let's work on this problem. So a worker at a pipe making company is stacking pipes for storage. The top layer on his stack has 3 pipes. Each of the next layers has one more pipe than the previous. So we're stacking them, right? So we've got like 3 pipes on the top. And then there's like next one down has more of them, so they nest inside each other. And the next one down has more of them, right? So you can kind of get a picture of what this thing is looking like. So if the stack has 10 layers, how many pipes will be in the final layer? So we know the first layer has 3 pipes. So we're just going to say that n is the number of layers. So it's just a number of layers. And a sub n is the number of pipes per layer. So like a sub 1, where n is 1, is 3 because we've got 3 pipes. That says second layer has one more pipe, which is 4. The third layer has one more pipe, which is 5. The fourth layer has one more pipe, which is 6. The fifth layer has one more pipe, which is 7. And I'm going to keep going all the way up until 10. 6, 7, 8, 9, 10. So we have 8, 9, 10, 11, and 12. Okay, so it looks like if we have 10 layers, we're going to have 12 pipes because the number of layers is the top one, and then a sub n is 12. So that says the 10th layer is going to have 12. That one's pretty straightforward. We're given the problem, we can kind of work it all the way out. Fortunately, it didn't say like 200th layer or something crazy like that. Okay, part B. Find a recursive formula for the number of pipes per layer. So when they say this word, this recursive thing, I'm going to flip to the back side just so I have a place to write down the word recursive, because that's a definition that we need to know. So when we say recursive, that's going to be a formula that depends on the previous I guess the previous a sub n, the previous number. So if we have a sub n, which is the output per term in sequence number, then we can say a sub n minus 1 is the previous term in the sequence. So for example, if we said this was a sub 10, the previous one is a sub 10 minus 1, which is a sub 9. If we were looking for a sub 1000, so the 1000's output, the previous term is 1000 minus 1, which is a sub 999. So we're going to use these two notations to write a new one. So we know that for our first layer, to get to our second layer, we just add 1 to it every single time. So for our next layer, so for the nth term, we take the previous one, a sub n minus 1, and we just add 1 to this. And here's the important part about this. You guys need to make sure that this is written in subscript form. When you have it in subscript form, that's going to make a big difference between having it in regular heights. So if I think about the letter of the line, right? So I'm going to draw some lines just like we had back in elementary school for drawing stuff. 1's all the way up and down, but this n minus 1 and this n need to be small. So what this says is if we're looking for the, let's just use 10 again. If we're looking for the 10th layer, right, that says we need to use the a sub 10 minus 1 plus 1 more. So if we're looking for the a sub 10, that says 10 minus 1 is 9 plus 1. So we'd say the a sub 9th plus 1 more. The a sub 9th is 11. Is 11 plus 1, which gives us 12, which is what we had in our original one. So a sub 10 equals 12 again. So we can check it by plugging a number in for that n. So we plug in 10. It says we plug in 10 on this side as well. Minus 1 says we use the previous one, add 1 more, and we get our total number of the output. Okay, so in contrast, we're going to use that as a contrast for this word called explicit, which says the explicit formula. So for recursive depends on the previous one. That says explicit is a formula that uses only the term number to get the output value, which remember we call a sub n. It uses only the term number, so it doesn't use the previous one. So let's go up here and look at this thing. So on your formula sheet, and I know it's been a little while since you've looked at this, so this is a good time to pause the video if you haven't and find this thing. Find the word arithmetic sequence, which is this thing we're calling this, arithmetic sequences. When you find the word arithmetic sequences, they're giving you the explicit formula. So they're giving you some information that you have to know, and then once you plug stuff in, you can figure it out. And they, by the way, on the right side, they tell you everything what it all is. You're welcome to use this on any quiz or test. They will give you a new one for the EOC, so if you're familiar with this now, you'll be good to go in the future. So it looks like the arithmetic sequence formula is a sub n equals a sub 1 plus n minus 1 times d. And I just copied this from right over here. So a sub n we know about. We're looking for an explicit formula, so we're going to keep our a sub n. We know what a sub 1 is. A sub 1 is going to be, let's see, a sub 1 is 3, so we're going to substitute that in, plus, we don't know the term number, our n minus 1, so this is kind of like our x, and this is kind of like our y. Our number of terms is our input values, and our a sub n is our output values, so those are going to stay the same. And then they say this d thing, so let's talk about what this d is. So d is the common difference. So I'm going to write that on my back of my vocab sheet. So d is our common difference, spell correctly, the common difference of the arithmetic sequences or series. It'll work the same thing. It's the same letter. We'll talk about what series are in a later video. So if we just say we want the common difference, that says we take any of them and we subtract. So if we look up here, 4 minus 3 is 1. 5 minus 4 is 1. 6 minus 5 is 1. 7 minus 6 is 1. 8 minus 7 is 1. And that's the key thing that makes this an arithmetic sequence. It's an arithmetic sequence because it has a common difference. So arithmetic sequences are a pattern of numbers that share a common difference. Not all sequences are arithmetic sequences. And that just says it's the same when you subtract every single time. So one of the common types is arithmetic. We'll talk about that other type in the next part. So our common difference here is going to be 1. And you can leave it like this. If you want to leave your explicit formula, that's fine. They might ask you to simplify, which we know how to do that. So if they ask you to simplify, then we can say a sub n equals 3 plus, well, 1 times n times n is n, and 1 times negative 1 is negative 1. So we have 1n minus 1. Combine our like terms, a sub n equals n. See, 3 minus 1 is 2. So if we just said 10, right, so we let's just do an example in here. Example, a sub 10 is equal to, replace the 10 plus 2. So a sub 10 should equal 12, which is what we figured out earlier when we figured out just counting it all the way up. So if we wanted to figure out like the 400th term, we can say a sub 400, this is example the next one, a sub 400 is equal to 400 plus 2. So somehow this guy made a stack of 400 pipes tall, right? Like it would have 402 pipes at the bottom one, which that's a ridiculous stack. Hopefully he'll set this numbers 10 or less, right? That'd be real tall. Okay, so at what layer will the worker encounter 17 pipes? So it's going to be kind of hard for us to use the recursive formula for this. We know that our a sub n, we don't know what number n is going to be 17. So let's see if we can use the formula, the explicit formula we just derived, and you can either use the bottom one or the second one. I'm going to use the second one because this is what's kind of standard for all of them. We know that a sub n is equal to 17. Our common difference hasn't changed. We still are adding 1 pipe every single time. What we don't know is n. We say, I have no idea what layer number it is. So a sub n equals our 3 plus n minus 1 times our 1. I was going to try to derive this again. I don't need to derive this again. So we know 17 equals 3 plus n minus 1 times 1. So we'll subtract 3 on both sides. We're going to get 14 equals, let's see, that cancels, n minus 1, because when we distribute we just get 1. So add 1 to both sides, so that says 15 equals n. So at the 15th layer, there are 17 pipes. That makes sense. If you just add 2 to them, right? So then subtract 2 to get your layer number. That works for this problem. It won't always work like that, but it'll always work for this problem. Okay, so I've got one more part for us, part E. So another worker uses similar process but has 14 pipes in the 10th layer. How many pipes are in his first layer? So we know the number of layers given to us is 10. We know our common difference is still the same thing because it says a similar process is 1. We know our last number is 14. What we don't know is the number of pipes in his first layer. We have no idea. So a sub n equals a sub 1 plus n minus 1 times d. I'm just going to write this down and substitute in what I know. So I know n is 10, so let's substitute that in. And my difference is still 1. I don't know my a sub 1, but I know my final amount is going to be 14. So we don't know the number, but we do know the output of that number. So we solve this problem just like normal. So 14 equals a sub 1 plus, let's see, 10 minus 1 is 9, times 1 is 9. Okay, let's subtract 9 to both sides, so we get a sub 1 equals 5. So we can say this worker has 5 pipes at his top layer. Fantastic. Okay, folks, so I'm going to turn this over very slowly, scroll up and down to make sure you can get anything that you need to. We'll have a practice worksheet for this one, so make sure that you grab it, get some practice before you try to take your quiz on 9.1 or 10.1. And also, you're going to definitely need to wait for the geometric sequence one. So work on just the arithmetic sequence one right now. The geometric sequence one will be up soon, and then you can finish that one as well. Okay, if you need to go back at any point, this is a video.